Alright guys, welcome back. We're on 7.1.3. We're looking at properties for justifying congruence. So we've been working on some triangle congruence proofs, and these are some ways that we can help justify those congruences. The first one we're going to look at is the reflexive property, which states that a term is equal to itself. That is, W equals W. For example, in the figure at the right, the length DB in triangle ADB is equal to the length DB in triangle CBD by the reflexive property. So DB equals DB. We have a couple other ways of stating the reflexive property in proofs, and I'm going to go over those as well. If you notice, what we've said in the paragraph there was that dB is equal to dB. On the top triangle, we have line dB in the middle, and in the bottom triangle we also have line dB. So that line is shared between the two triangles. So sometimes when we're writing our proofs, we'll write shared side as a reason. So the reflexive property is the same thing as a shared side. You may also have a shared angle between two triangles. If you had something like, let's see if I can draw it, something like this, we can see that this angle would be part of the top triangle, the smaller triangle, and part of the larger triangle. So this would be a shared angle and would also be a reflexive property. If this was angle A, you could say angle A is congruent to angle A because of the reflexive property, or because it's a shared angle. Another phrase that gets used in the book a lot is congruent to self, congruent to itself. So when we have a shared angle or a shared side like this, using the reflexive property, we may say that it is congruent to itself. All just reworkings of the reflexive property. The next one we're going to look at is the symmetric property, that states for any two terms A and B, if A equals B, then B equals A. So for example, see the diagram at the right. Since the measure of angle B equals the measure of angle E, then the measure of angle E must also equal the measure of angle B by symmetric property. So symmetric property just means that we can flip them onto the other side of the equal sign. If A equals B, then B equals A. The transitive property is a little different. It states that for any three terms, if A equals B and B equals C, then A equals C. For example, see the diagram at the right. Since B equals E, and the measure of E equals 50 degrees, then the measure of B must also equal 50 degrees. So we had a three-line logic there, right? We had measure of angle B equals measure of angle E. Then we had measure of angle E equals 50, which then let us say that these two, measure of angle B, must also equal 50 degrees. Okay, that is it. These are just three properties that are handy to keep in your mind when you're writing triangle proofs. See you next time.